We will now use the ideas and concepts of alternating current to solve examination questions. In this examination question, a metal wire is held taut between the poles of a permanent magnet, as illustrated in figure 7.1. A cathode oscilloscope is connected between the ends of the wire. The Y plate is adjusted to 1 millivolt per centimeter. This means that for any displacement of 1 centimeter vertically, you need a voltage of 1.0 millivolt. And the time base is 0.5 millisecond per centimeter, meaning horizontally in the x direction, a displacement of 1 centimeter requires a time of 0.5 millisecond. The wire is plugged at its center. Figure 7.2 shows the trace seen on the cathode oscilloscope. Now from this graph, we can find the VO, which is a peak voltage. And you can see that the peak voltage is 1.5 centimeter. We know that 1 centimeter vertically is 1 millivolt. So 1.5 centimeter will be 1.5 divided by 1 times 1. This will give you 1.5 millivolt. That means your VO is 1.5 millivolt. And then horizontally, this is a period. It covers 6 centimeter. We know that 1 centimeter represents 0.5 millisecond. So 6 centimeter will represent 6 over 1 times 0.5. This will give you 3 milliseconds. So we know the period is 3 milliseconds. What you can obtain from this graph? We can obtain two important information from this graph. First is the period, and secondly is the peak voltage VO. And from the period, you can find the frequency, and from the peak voltage, you can find the root mean square voltage. Making reference to the laws of electromagnetic induction suggests why an EMF is induced in a wire. The answer is that the wire cuts the magnetic field. So EMF is induced when there is a change in magnetic flux linking the wire. Then in part 2, suggests why the EMF is alternating. Direction of motion of the wire changes, meaning the wire is moving up and down. The wire moves up and down, so EMF induced in opposite directions. In part B, use figure 7.2 and the cathode oscilloscope setting to determine the equation representing the induced alternating EMF. The general equation to represent an induced alternating current or EMF or voltage is this formula. V equals to V naught sine 2 pi ft. 2 pi f actually is omega. So in order to get the equation, we need to know the peak voltage, which is 1.5 millivolt. And then we need to find omega, which is 2 pi f or 2 pi over t, which will give you 2093 radian per second. Then you substitute the values to do this equation. You get V equals to 1.5 sine 2093 t. That is the general equation representing the induced alternating EMF. And this is the theory that you need to know. This is the general equation for alternating EMF. And then we can get the V naught, the peak voltage, and the period from this graph.